Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to another NL Math Man Math Help stream. Here today. Here today we've got Lazy Days as the title. Took a little bit of a pun on days, because I like puns. Puns are the highest form of wit, right? Like if Mitch Hedberg did a set that was entirely puns, it would be just like that would be one of the crowning achievements of humanity, basically. You know. Anyway, it's unfortunate. It's a tragedy. Anyway, yes, we've got a nice picture of Flurry and Smokey here alongside me. They're looking very, very sleepy in these pictures. Perhaps, perhaps at this point they were just tucking in for their afternoon naps. I would imagine. You know, laying out in the snow around the cabin. It's clearly around the cabin. I can see because up in the corner there you can see the very bottom of a snowshoe just stuck down above the E in stream starts soon. Yep, some more buckets over there above the STR. Buckets used to pull some gray water up from the lake. Because we use lake water for gray water, right? So like dishwashing, toilet flushing, all that kind of stuff. Although just last year, actually, we actually don't need to do that anymore. Now, starting this next year, we put a well in. We had some excavating done and put in a dug well out at the cabin, which is quite fun. We put it down low enough that apparently it shouldn't have frozen during the winter. But yeah, I'm not sure if it's my parents were able to get any water through it last they were out. But we do have a dug well out there, and we actually here in Newfoundland, or I don't know if Canada in general has it, but it's a provincial program I know where you can get your water tested, right? So you can bring in little jars or jugs of water or whatever from a dug well or from your home or anything like that, and then you can bring it to I think they had to bring it to the DMV in Gander, I believe, because that's just the office that they were using. But anyway, they brought it in there and got it tested, and apparently, yeah, it's safe to drink according to the test. Because it's groundwater, right? It's filtered through the earth, which is a very good filter. However, I think my parents are still gonna opt to get some spring water on their way. That is one thing we're very, very blessed with in Newfoundland and in Canada in general, is the amount of fresh water that we have. Like, um, Canada has like a vast percentage of the Earth's fresh water, just because the country is so dotted with lakes, and the island of Newfoundland is no exception, right? And the water table is fairly high because here on the island, we get a lot of precipitation. So the really high water table means it's relatively easy to make a dug well as well. Anyway, got off onto talking about wells here when my picture is of little sleepy doggies just tucking in for a nap. We've got little Flurry over here. Give her some pets. Pat, 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 pat. There we go. And then little Smokey over here. Pat, 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 pat. Good boy. Yeah, he's a good boy. Okay. So today now, without further rambling about, rather be at the cabin or whatever, I'm going to go ahead and start talking about some mathematics down here below me. So today we're going to start off with converting metric units, right? I have covered that topic on here before, but I'm going to do it again because it's a super common one that comes up in a lot of the courses. I believe Carly is just starting a course that is pretty much entirely on converting metric units, so super important for her to pay attention to that one. But it's a really common topic that comes up again and again and again. You never get away from that one until you're done the program, right? Converting units of area, I'm going to go over that one kind of quick. There's a few questions from recent activity that Ashley did that I want to go over. Then at the bottom there is finding angles using angle properties. So that'll be the course that Nick is currently working on. Nick D, actually, because we've got two Nicks. But the other Nick isn't doing any math, so he knows it's not about him, so I don't know why I specified. Anyway, yeah. So, yeah, without further ado, let's tuck into this one. I'm going to switch on over to let's see. So we're going to do metric units first. So let me bring up, actually first let's introduce the metric conversion ladder is what this is called. So I move over here, and we can see this thing over here on the side. So what we call this, So Carly, I sent you a copy of this along with your next course. And say if you were on your test or whatever, you will have access to this as well, so you won't be expected to remember it. What this shows is basically how we convert between, well, not all of the metric units, but a lot of them. Because one of the nice things about metric is entirely powers of 10, right? Whereas in, say, in imperial, there can be random numbers, like at 1760 yards per mile, right? Metric doesn't, we don't mess with the, 1760s or anything like that in metric. It's strictly powers of 10, right? So I'm going to zoom in here a little bit more. We see the way this works is we multiply by 10 for each step we go down. We divide by 10 for each step we go up. Right? And in metric, the important part is it's the prefix. The prefix, or the part that goes on the front of the word, is what's important in metric. So let me start making some notes here that I'll send. What matters is the prefix, or the first letter of the unit, right? So say we have KM, or I don't know, ML, or say those are common ones that we see. KM, ML, we say, I don't know, KG, CM. So the underlined letters tell us how big the unit is. Now, don't mind me ending my sentence with a preposition. Ooh, geez. You'd think I'm not a cool science fact. The periodic table is put together after a man dreamed the way to do so. That is pretty cool. I like that. Yeah. So it came to him in a dream how to organize the periodic table. Boy, that's that's pretty great. I like that. Yeah. So like was I guess that must have been a nightmare, right? He was like, oh, just sort of fumbling through a fog of like haphazardly arranged elements, and then it was like, boy, I could put it in sort of like a U looking shape. That's pretty fun, Albert Einstein. Yeah, I'll keep that one in mind. Maybe I'll look up that anecdote to tell students next time I'm doing a chemistry course and they're like gobsmacked by trying to understand what in the world the periodic table means. It's like this came to someone in a dream. It was a fever dream, fueled by, I don't know, alcohol and hallucinogens. Anyway, that's what scientists are up to, right? You know that. Scientists are just getting like whacked out of their minds. It's true. I have another anecdote. There was another anecdote about I should look this one up. This is a true anecdote, right? All anecdotes are true, obviously. There was a mathematician who like did was like a functioning addict of some like hard drug, like I don't know, like amphetamines or something. Someone bet him that he couldn't stop, and he stopped for a month, and then afterwards he was like, "You have now set mathematics back for a month." Anyway, scientists are weird. That's my point. Not like Big Bang Theory weird either. I mean like legitimately kind of bonkers. Anyway, for metric units, like I was saying, what matters is the prefix. The first letter of the unit, so KM, ML, KG, CM, the underlying letters tell us how big the unit is, right? So okay, so the circled letters tell us what the unit is measuring, right? M is meters, which measures length, right? G is grams, which measures mass. Mass is not weight. Mass is not weight. Mass is very similar to weight, but it isn't weight, right? That's a really small point. Carly, when you're doing this course, it's not going to matter to you to know the difference between mass and weight. But when you go on and do science courses later, like some physics courses, we will discuss the difference between those two. Because weight is the force of gravity that's acting on something, whereas mass is like the amount of matter that a thing is made up of, right? So your weight, if you go into outer space, your weight will change because gravity's pulling on you differently, but your mass will stay the same. Really small difference, but you know, it is an important difference later on. And L is liters. Liters measure volume. Okay? So I'm going to put this over here in a bubble because that's not super important. And there's way, way, way more of these in metric, right? There's, obviously seconds for time, hertz for frequency, um, I don't know, ohms for resistance. There's loads and loads and loads of stuff, right? But the important part is the first one, right? So the prefixes are what we read from the metric ladder, right? So over here on the side, right, we see that kilometers, right? When we go up from meters to kilometers, we're going up 3 steps, right? So, for example, we have this, say, I'm just going to do out a small section of it like so, right? So now we've got meters here, we've got decameters here, we've got hectometers here, and we've got kilometers here. Every time we go up 1 step, we multiply by 10, right? Every time we go up a step, we multiply by 10, right? But it's another 10 that we're multiplying by. So when we go from meters to kilometers, of course, you probably already know there's 1,000 kilometers in a meter. So it's not, occasionally I'll get a student who will see one like this and do call that times 30, but it's not because it's times 3 tens or times 10 3 times. Oh, Dmitry Mendeleev. Okay. Mendeleev? I don't know. My Russian pronunciation is not very good. Yeah, I've definitely heard that name before, Albert Einstein. Although I may have heard it from the game Sid Meier's Civilization 6 and him being one of the great scientists in it. I might have. I might have learned a lot of my history through Civilopedia. But anyway, yeah, I'm definitely gonna look that up. That is fun. That's a fun anecdote. So there we go. So to go from meters to kilometers, you see on my course sheet when I do science? Yeah, yeah, of course. Yeah. Oh, I didn't realize that you didn't have a science course currently. Yeah, you can definitely work on a science one. How about just send me an email and yeah, I can send you your CSS if that's what you mean, so you can check and see which science courses you're able to do. If you haven't done any science yet, which I don't think you have, I believe you'll have a choice of either the grade 10. Um, let's see, there's one chemistry, one physics, one biology, and one earth science, I think. So there will be 4 options for you. The problem there is that afterwards you'll have to get a set of 6, and the sets of 6, we don't have a set of 6 earth science, unfortunately. We only have a set of 6 physics, a set of 6 chemistry, and a set of biology. And you have to do the first one in order to be able to do one of those sets, right? So earth science is probably the easiest of the 4 starter courses, but then you don't get to go on and do earth science afterwards, unfortunately. So if you want to check out and see, like, say, what two of the courses will be, two of the different subjects will be like, I would recommend, say, maybe you do the intro biology and then either the intro chemistry or physics. Personally, I like the physics best, but that's just me, right? People tend to prefer biology because biology is more of a reading and conceptual sort of studying course, whereas physics and chemistry are a bit more computation. Oh, you did the bio already. Okay, yeah. So then your option now will be either the intro chem, the intro physics, or the intro earth science. You can do the earth science. It's a fine course. Just you can't then go on and do 6 more earth science afterwards. And now, Carly, just to get back to finishing up with these notes here. So when you're going down, right, Km to HM, dividing by 10, HM to DAM, dividing by 10, DAM to M, you're dividing by 10, right? So if you're going down the steps or the ladder, I don't know why we call it a ladder when it's clearly stairs, but anyway. When we go down, it's going to be divide 10, divide 10, divide 10, which is divide by 1,000, right? And just to show you the way it will be written in later courses, you're not going to see it written like this in these courses that you're doing right now. But times by 1,000 is also written as times 10 to the power of 3, right? 10 to the power of 3 is 3 tens multiplied together, or a 1 with 3 zeros. Going down from kilometers to meters, we're going to be dividing by 3 tens, dividing by 1,000, dividing by 10 to the power of 3. Now, do my eyes deceive me, or did my life cam just get a heck of a lot dimmer all of a sudden? Weird. Anyway, yeah, see? There it goes again. Bonkers. All right. But anyway, I'm now going to switch over and carry on with doing a few examples out of the book. So, Carly, this is the pre-test for the unit that you're currently starting. You're not responsible for this page, so it's a really good one for me to take a look at. And it's also got a good sort of smattering of the different types of questions that you're going to be dealing with throughout this unit. So I'm going to work down through a few of the ones over here. Yeah, let's do these first few ones here real quick. Okay, so this is Math 2016, and this is the pre-test. That's page, what is that? 138. So if you're looking it up in your book just to see what ones I'm doing to follow along, that is, yeah, page 138. So then question 1, 9 cm equals, well, oh, this is a bit of a pain, isn't it? In it. Tell you what, I'm going to copy out a whole bunch of these, and then we're going to switch back over to my to the ladder so that we can see it, right? Because I can't right now. I don't have a thing set up to show 2 PDFs at once on stream. So I'm just going to copy out a few of these guys, and we're going to pop over and see how we can figure them out. Yeah, it's a capital L, not a lowercase l. All right, riveting content here with me just doing some handwriting, you know. These things happen. 100 kilograms equals some number of grams, and then 4,800 kilograms equals some number of tons. Now, tons are a weird one because there's an imperial ton and a metric ton. We are, of course, dealing with the metric ton. But anyway, I'll get to that in a sec. So now let's flick on back over to my conversion ladder. Here we go. Yeah, good. That's pretty legible there in the corner, isn't it? Yeah, it's totally seeable. Seeable? Seeable. All right. So now, 9 centimeters to millimeters. Well, that's a super common conversion, right? You see that one all the time. Centimeters to millimeters. I mean, that's even on your ruler, right? Like, look, right here. See? See there? We know that that's 10 millimeters, and it's the same as 1 centimeter, right? Whoa. Tough to see where it's transparent. But either way, right, we already know on the ruler. Some of these you could check. You could, if you were on a test and you were really unsure, you could check it. Oh, come on now. Why? Hello in there. See if I can get some brightness. Weird. Anyway, so 9 centimeters, 90 millimeters. You're going down one step means you're times by 10. Meters to centimeters, where you're going down 2 steps, you're going to times by 100. Right? I think you're seeing where this is going. Meters to centimeters, now we're going up 1 step. We're going up 1 step, we're going to divide by 10. 2.5 kilometers to meters, it's 2,500. Now with ones like these where we're not even dealing with any of the weird ones, right? There's no hectometers and decameters and crap going on here. So I mean these ones you probably could have done already just from the start, just from knowing these things, right? Because just from living in Canada or any country that uses the metric system, you end up seeing a lot of these just in your day-to-day life, right? Like the conversion between liters and milliliters and, you know, that kind of stuff. 10.8 grams. We're going to go from grams to milligrams. This one's going to be now times 1,000. So it's going to be 10,800 milligrams. That's a comma, not a decimal. 1,000 kilograms is how many grams? Well, it's going to be 1,000 with another 3 zeros. So it's actually 100,000 grams. And 4,800 kilograms. Well, there's 1,000 kilograms in a metric ton. So it's just going to be 4.8 T. You don't need this one. You're not going to be given on your sheet. But yeah, it's just worth remembering that 1 ton equals 1,000 kg. That's just that one. I don't think will be given to you actually. So I think you will have to memorize that a metric ton is the same as 1,000 kilograms. But it's not super difficult. So now, before I get finished with this one, I'm going to do an example of some of the word problems as well. So it's harder to see on this display, so maybe I'll pop back over to here. There we go. Robin needs 5 meters of ribbon. Ribbon comes in rolls of 250 centimeters each. How many rolls will she have to buy? Okay, this is better. Yeah, this is the stuff I wanted to do here today. Great. Good. Because when we're doing a word problem like this, there are 2 steps that we always have to follow. The first step in all of these, oh, look, my pen is sometimes transparent, sometimes not. That's too bad. This was my favorite prop for a while. So for question 11 then, or for any word problem, an important thing to do first is to convert all measurements to the same unit. It's the first thing you need to do, right? Because here, she needs 5 meters of ribbon, but it comes in 250 centimeter rolls. How many rolls would she have to buy? Well, we can't just take meters and divide by centimeters, right? We either have to convert the meters into centimeters or the centimeters into meters. So I'm going to go ahead and say 5 meters equals 500 centimeters. Then I'm just going to do 500 cm divide by 250 cm per roll, and that's going to give me 2 rolls. Right? So that's fairly straightforward. But the important thing here, like the main thing that this type of question is testing, is that you remember that you need to convert all your units to the same form before you do your computation. Yeah, let's do the rest of these. These are good examples of the types of questions that you're going to get on tests here. So 12 servings of the same size were made from a box of cereal of mass that 336. How much cereal was in each serving? Oh, okay, sure. 12 equal servings. Well, how do we split something into equal sizes? You divide. Right, so here now we don't even need to convert. We're just dividing by 12. 336 divided by 12 is going to be 300 divided by 12. 336 divided by 12. Why am I blanking on that? 28. Yes, of course. Yeah, 25. So it's 25 plus 3, 28. 28 gram per serving. Easy. Right? That's all you got to do there. So yes, these do seem pretty easy, don't they? But hey, don't look a gift horse in the mouth, right? This Math 2016, not super difficult. Just the main thing you got to remember is this rule up here, to be honest. This is where, that's really the only place where people tend to lose marks. So, Miss Cardinal's car can go 11.3 kilometers on a liter of fuel. Capacity of the car's fuel tank is 80 liters. How far can you drive on a full tank of fuel? Okay, well, there's lots of different ways we could figure this one out. I'm partial to setting it up as 11.3 kilometers per 1 liter, right? And then we can do a cross multiply. We can say that now we want to find out, well, it's some unknown number of kilometers per 80 liters, right? And this is sort of the way I showed for unit conversions before. Here now, we're going to cross multiply. You, of course, don't need to write that word out. I just do it to make it very clear what we're doing. It'll be 11.3 times 80 on the left is going to equal x times 1 on the right. So it's just going to be 11.3 times 80. 904. Probably could have done that in my head, right? Because 11 times 80 is easy. And then 0.3 times 80 is the same as 3 times 8 times 10. No, it's just 3 times 8. Anyway, look at me. Even getting it wrong after the fact. So that's going to be 904. Another way that I like to solve questions like this is by, say we've got 11.3 kilometers, right? And it's going to be multiplied by 80 liters. Yeah, 11.3 kilometers per liter multiplied by 80 liters, right? And one way we can think about it like this, one reason this is useful to us is because it allows us kind of to keep our units in here and we see how it cancels. And that sort of allows us to check and make sure that we're right as we're going. Because if we end up with a unit other than kilometers, we know that we're off a bit, right? Because we know that we're looking for a distance. And here now we've got liters on top and we've got liters on bottom. So we know those are going to cancel. And we're going to be left with 904 kilometers, right? You don't need to do both these methods, but either one of these will work. Okay, so that is a good overview, I think, of Math 2016. Charlie, I hope that is useful to you. Next up, let me switch back over to my intro, my lazy days over here. See little buddies having a yawn. Right, so now we're doing converting units of area next. Okay, so let me bounce over to these questions. Here we go. Yeah, I could zoom in a bit more. I'm going to do questions 6 and 7, so I'm going to do both questions on this page. Let's zoom in a little. Zoom in a lot. And how about we pop over to the other display so I've got more room to work. There we go. Good. So perform the following conversions. Well, this is now Math 1102A Unit 3. And this is just a bit of a recap of this unit. Now, Ashley, I know that you've already moved past this, so congratulations, you got these all done. That was great. I am just going to go over a bit of this because you are going to see this topic again. I don't want to, at the risk of beating it to death, I do want to, just reiterate the way that we solve these ones. So 6a is going to be 576 inches squared to some number of feet squared, right? So how are we going to find that? Well, part of what we've got to do is we've got to go back over to our formula sheet, which is right here, right? And let's go over so we can see it a bit bigger. On our formula sheet, this is the formula sheet you were given for this activity, right? We see up here that we have 3 different conversion factors that were given, right? Now, for whatever, 5, because we've got the metrics there as well. So let me write these down over here on the side so I don't have to be flicking back all the time. So here's the conversions. We've got 1 square meter equals 10,000 square centimeters, right? 1 square kilometer is going to equal 1,000,000 square meters, right? We've got 1 foot squared equals 144 inches squared. We've got 1 yard squared equals 9 feet squared. And we've got 1 yard squared equals 1296 inches squared. Okay? So you get those from your conversion sheet, from your formula sheet. Those will be provided to you. You will notice, of course, like we talked about before, that the conversion factor is the linear factor, but squared, right? And just again, to really briefly draw out the reason for why. I know I've done this on stream like 3 or 4 times, but I do, at the risk of repeating myself over and over, I do want to sort of show the reasoning behind why the conversion factors are not the same, right? Because if we have an area that's 1 foot by 1 foot, that is 1 foot squared, right? And that is the same as an area that is, of course, 12 inches by 12 inches, right? Because a foot is 12 inches. So a foot squared is 12 inches by 12 inches. That's going to be 144 inches squared because the area is equal to LW. Area is equal to 1 times 1. Area is equal to 1 foot squared. Area is equal to length times width. Area is equal to 12 times 12. Area is equal to 144 inches squared. Okay? And I'm just gonna keep writing that out, right, for you to take a look at. I am going to bump that brightness back up a little bit there. Boy, oh boy. This camera, like I said at the start, this little tiny one I'm using as my dock cam, I found in a drawer randomly. I think this camera is probably like, I don't know, it's a solid like 15 years old probably. I'm lucky it even has USB on it. No, I mean, obviously there was USB 15 years ago. Anyway, so now I'm going to bounce back over so we can see the activity that we're on. So now we have 576 inches equals some number of feet squared. Well, we know that 1 foot squared is 144 inches squared, right? So there's a lot of ways we can think about multiplying these out. Now, Ashley, you've been doing your cross multiplying really well, so I think that's a great thing to carry on with. We know there's 1 foot squared per every 144 inches squared. So that means there's some unknown number of feet squared per 576 inches squared, right? This might be a little bit of an overcomplicated way to do this exact question, but it does get there in the end, and it makes a lot of sense. So now we're going to cross multiply. and we are going to get 576 equals 144x. So we've got to do 576 over 144 equals x, which will then give us a nice simple 4. So that's 4 feet squared. Okay. Say we were to do question B. Slide over. Yeah, we can see B just fine. I'm going to go down through all of these ones here. So we've got 0.5 meters squared equals some unknown number of centimeters squared, right? Another way we can do this is by sort of multiplying by our conversion factor, right? So if we've got 0.5 meters squared, the idea is now, when we're multiplying by our conversion factor, we have to set it up so that, what the heck? Hold on. We have to set it up so that our meters squared cancel, and then we end up with centimeters squared, right? So we're going to need, we know that the conversion factor that we're using is 1 meter squared is 10,000 centimeters squared. We have that over here. So we're going to have our 10,000 centimeters squared divided by 1 meter squared. Once we multiply these, then the meter squareds and meter squareds are going to cancel, and all we're doing is doing half of 10,000. Half of 10,000 is, of course, 5,000. So that's 5,000. Right? Sorted. Easy peasy. Let's carry on. Question C. '81 feet squared. I'm going to multiply that because we're trying to get that into yards, right? And we know that a yard squared equals 9 feet squared. So we need to have feet on the bottom. We need feet on the bottom so that yards are what's left on top. So we're going to have our 1 yard squared per 9 feet squared. That's going to equal 81 over 9 yards squared. And of course, 81 over 9 is equal to 9. So 81 square feet, 9 square yards. Question D. .5 square kilometers. That's a significant amount of area. Now we want to get them into meters squared. So we know we're going to need meters squared on top, right? So this is the conversion factor that we're using. And we know meters need to be on top because that's the unit we want to get to afterwards. So it's going to be a million. Oh, that should be a 0. Divided by 1 kilometer squared. Right, so it's just going to be 2.5 times a million, which is of course going to be 2.5 million meters squared. Right, running out of space there, but I think you see where I'm going with that. E and F next. E is going to be 3 feet squared, and we're converting it into inches. Right, so we look over here, we see our feet to inches is 144 to 1. Right? And we need to have inches on top because we want inches to be what's left over after we're done. Oh, 144 inches squared per 1 foot squared. We multiply these out, and we're going to have 3 times 144, which is going to be 450 minus 12, which is going to be 438. 432. What? Oh, 6 times 3. Don't mind me. Don't mind me. See, I'm off today. I haven't had my V8. Not sponsored by V8. 432 inches squared. And the reason we get to this, like I'm saying, right, is because the feet squared cancel with the feet squared here. Kind of like how this feet squared cancels with this feet squared, and this, kilometer squared cancels with this kilometer squared. and so on, just like I showed up there, right? That's the meat of this, is that it's all canceling out. And I'm just going to go on and do F as well. And then we'll have managed to cover this whole one. So oh, hello, Slayer Darth. Welcome. Just tearing through some metric conversion, well, some area conversion questions here. Thanks for dropping by. So for question F then, we have 6 yard squared, right? And we want to get it to feet squared. So we look over here, we have this conversion factor. 1 yard squared is 9 feet squared. We want feet left over afterwards, so we know feet is what needs to be on top. So we have 9 feet squared divided by 1 yard squared. That's our conversion factor. Once we multiply now, we're going to have 9 times 6, 54. That's going to be 54 square feet, right? Because the yards cancel with yards. All right. So let's see, what's next? I want to do question 7 on this activity as well. Okay, so that was question 6. Question 7. Oh, let's move back over to my document display so we can see it a little better. Zoom out, zoom out, zoom out. John's about to install a new tile floor in his basement. Metric, you mean the right way to measure? Yeah, exactly. No kappa. No kappa. Metric is yeah, of course, it's the superior system, clearly. Right? Because power's a 10. Oh, it's good stuff. So John's about to install a new tile floor in his basement. The main room in his basement has measurements as shown in the illustration. 16 feet by 10 feet. In square feet, calculate the area of the floor to be covered by tiling. Okay, well that part's relatively straightforward, In it blood. So to find the area, this is going to be 16 times 10 equals 160 feet squared. All right, easy. What's part B? Part B is convert the area of the floor into square inches. Okay. So now part B is kind of like what we were just doing above in question 6, right? So we're converting now this 160 feet squared. And I'm going to keep doing the conversions like I did over here. So I'm not going to cross multiply, though I could, right? But I find this one over here to be a good way of imagining it as well, right? So we have our conversion factor here, which is 1 foot squared is 144 inches squared. We know we need inches to be the one that's on top because we want to have inches after we're done. So it's 144 inches squared per every 1 foot squared. Once we multiply this out now, we're going to be going over. So let me just write this out down below. It's a little sloppy, but I ran out of space. 160 times 144, 23,040 inches squared. Okay, now for part C, John plans on using square tiles that measure 10 inches per side. What's the area of each tile? Well, that's not hard, right? So it's going to be 10 inches times 10 inches, which is going to be 100 square inches, right? So now it says these tiles are sold in boxes of 50 tiles per box. How many boxes will John need to purchase? Make sure he has enough to cover the entire floor. All right, cool. So for this one, first we need to figure out how much area is covered by the one box, right? So 50 tiles, right? And we're going to multiply that by 100 inches squared per every tile, right? Each tile is 100 inches squared. There's 50 of them, so pretty clearly it's going to be 50 times 100. Now, whether you write out your working exactly like this or not, I'm not super concerned about, right? Like, just conceptually, I'm sure it makes, it's fairly obvious that you've got to do 50 times 100, right? Which is, of course, going to be 5,000 square inches per box, right? It should actually be tiles per box over here. Tiles per box and inches per tile works out to be then inches squared per box, right? Just to show that the the arithmetic actually works out even with the units there. And it is a useful thing to start including, especially when you go on to like physics courses and stuff like that. If you ever do, um, yeah, it really helps you check your work because you can know the units you're supposed to get, and you know what units you've got from your working. You can sort of have a metric to tell if you've done it correctly yet. But this is just how many inches squared of area is covered in one box. So now we need to figure out how many boxes the guy's going to need. Well, that's of course going to be 23040, or his total amount of inches squared that's required, divided by 5,000 inches squared per box. And this now actually will get us units of box, right? Because if we're, um, it's in the denominator of the denominator, which the denominator of the denominator is the numerator. Anyway, I'm not going to do this one in my head. I mean, it's going to be 5, but 4.6. So since this is a word problem, I would expect you to write out, John will need to buy 5 boxes, right? He needs 4.6, but the guy at Home Depot or whatever is probably not going to give you 0.6 of a box, right? So you're probably going to have to buy 5, right? Imperial to imperial conversion factors don't make any logical sense. Yeah, they really don't, do they? Right? Like 12, okay, at least 12. 12's an okay number, like it's a dozen, right? That makes sense. But then when you're looking at like yards to mile and it's what, like 1760? That's a bit silly. Like, where'd that number come from? Why 1760, right? Although I will say, for the imperial system, it has one saving grace in that it's useful for teaching kids about fractions, right? When you talk about like fractional parts of inches, right? Like sixteenths and eighths and quarters of an inch and stuff like that, right? People who are used to doing carpentry in imperial are pretty good with fraction math because you'd have to be. Saw an interesting article on Reddit there the other day, because obviously I'm a cultured internet person who reads Reddit. Yes, 58, 20 feet to a mile, that's right. But it was mentioning that, tradespeople and people in, blue collar jobs actually do math all day long, like way more than people in white collar jobs. And it makes sense, right? Like a white collar job, like an analyst or something like that, needs to understand the concepts behind the math, but they're probably not doing a whole lot of arithmetic for their job. But anybody who's out there like building stuff, like a carpenter or a bricklayer or electrician or plumber or anybody who's out building things is doing math all the time. 8 pints to a gallon, kind of used to. 2 pints to a quart, and 4 quarts to a gallon. Yeah. Although pints are a slightly different size some places, right? I'm pretty sure that a British pint or an imperial pint is slightly bigger than an American pint. I think. I don't know. Pint is obviously very important, right? You want to get every drop of that beer that you paid for down to pub. You know, it's like a pint. Right? A pint's going to cost you what, like $8? Yeah, that's ridiculous in Canada, anyway. But yeah, so that Ashley, that was the topic I wanted to get through for you there with that nice, very colorful sheet. I will send you those workings there now after I'm done for today. Now, the next topic that I wanted to get onto today. Let's see. Not that not that window. The next topic that I wanted to get onto today was finding angles using angle properties. Yes. Okay. This is a good one. So Nick, this is the unit that you are working on currently. I know this unit that you're doing is a little bit confusing because it starts off with all this stuff about proofs and like how you arrange formal proofs and all that. And I'm like, you do have to do it, but I'm not super concerned about it. For one, there's not much on your test. I'll tell you right now, there's not a whole lot on your test about proofs. There's a little bit. There's like one question, right? The main thing I'm concerned about is if you can do the questions like on the assignment, which are very much like these ones. So I'm going to walk down through some of these. Oh, Slayer Darth, you've been looking into calculus. Yeah, calculus is fun. I do like I like how useful it is for a lot of applied sciences, like say physics and engineering and things, right? Because of course with derivatives and integrals, what we're finding is the slope of a line and the area under the line. stream quite geometry heavy. It just so happens that these are the courses that my students are working on right now. I'm so basically the way the program works that I teach is students are sort of coming and going all the time. Currently, I've got 23, I think. Um, but yeah, they you work through the high school curriculum sort of at their own pace, and I sort of teach to whatever problems they're having, and I help them with whatever they're working on at the time. So yeah, it just so happens that geometry is something that a lot of my students are working on right now. We actually don't go on and do calculus, unfortunately, just because that's where the Newfoundland high school curriculum ends. We end just at pre-calc, so we end with logs. Um, yeah, we'll be talking about logs eventually, although I don't think no Troy is close to that course. I think Troy is one or two courses off finishing the academic math. But it just so happens that this is where the students are right now. Right. So yeah, Nick, these are some examples that are very similar to the ones that are on your first assignment in this course. These are from the review sheet, as you see up here. And of course, the review sheets are not for marks. You don't have to submit these, so I'm free to sort of go down through and show you how to do some of them. This now is math 2101A Unit 2. Right. Determine the missing values in the diagrams. Okay, so what I am going to do, focus on certain branches of math more than others. Need to brush up on my geometry again. Well, sure. Yeah, there is. I mean, every aspect of math is useful for sure, and seeing the way that they sort of combine together, right? And like I was mentioning about calculus, right? The way that it's actually um, there is a sort of a geometry aspect to it because, of course, when we draw out a line or any sort of curve, right, in a coordinate plane, that has a very spatial sort of characteristic to it, right? And then the derivative of a line finds the slope, right? Whereas the integral of a line finds the area underneath it, which can be again can be super useful in sort of combining, parts of geometry with parts of calculus and things like that. Angle x is 60 degrees. As opposite angles have the same value. That's exactly right. It does indeed. Now, 1A, whoever drew this one, I'm not a big fan. I'm not a big fan of whoever drew this one, and I will explain why now in a second. Because the thing is, we actually don't have enough info to determine angle Z and angle Y as it's written there. Right? And why not? Why don't we? Well, the reason we don't have enough information is because we're not actually told, there's no symbol there telling us that this line and this line are parallel. Now, I know from knowing what the unit is on that they want us to assume that these are parallel. But normally, right, and I'm going to be very particular about this, whenever on a test or anything like that, there would have to be an arrow here and an arrow here, right? With this notation now, what this indicates is that these two lines are parallel. As soon as we know that these lines are parallel, then we have plenty of information to go figure out angle Z and angle Y. So Nick, when you see this question in 2101A Unit 2 review, you are supposed to assume that those guys are parallel. We know that x here is 60 degrees, right? Because these are opposite. Right? And now if this line and this line are parallel, now what we know is that an X created around, like a cross created around it here, and this one here are going to be the same. Because when there's a bisector, sort of a line that comes through both there, yeah, since Z and Y are on a straight line, yes, we know that Z plus Y. We do know that. That's right. Z and Y are on a straight line, so Z plus Y have to be 180. Yep, that's true. Once you know the values for either angle, we subtract from 180, get the value for the other. Yeah, absolutely. Yep. And that's a straight line, right? Because a straight line is always 180. Now, because these two are parallel, though, we know that this sort of full section here and this full section here are actually the same, right? They have all the same measurements because this line going across, this one is perfectly straight. If this line was curved, we'd be out of luck. We wouldn't have any way to solve other than to break out the protractor. But here now, because it's a straight line, we know that this 60 and this y have to be equal, right? Y equals 60, and we can call this corresponding. You don't need to give a reason here, and personally, I am not super concerned. Even on the questions that ask you for a reason, I'll still include it, right? Because it's written there in the key and all that. But personally, for me, I think it's much more valuable to be able to apply the rule than it is to be able to remember the name of the rule. But that's just my own opinion. Angle Z then, like we're saying, we know angle Z is 120 degrees. And there's a lot of ways we can determine that, right? We can subtract y from 180 and get 120. We can do the same thing down here, right? Because we know this angle plus this angle have to be 180, so that this one has to be 120, and then Z corresponds to that one, right? There's a whole bunch of different ways that we can solve a lot of these questions. And that's sort of what I want you to see here today. Now this one down here, this is a good one. I like these. This one has a sort of two triangles with two parallel lines. And here you'll notice that they did do the diagram correctly. This notation and this notation that I'm circling with my cursor here, that is what you need to do to show that two lines are parallel. Just here now for 1b, let me switch up, do this in blue. So for 1b, we have a right triangle. Like so. And we have another line going across it like this, right? And we know this and this are parallel. Okay. We know this is a 90-degree angle, which is super important. We calling this angle C. This is angle A. This is angle B out here. And we know this guy down here is 32 degrees. Yeah, it's one shape. It's one triangle sort of split right down the middle there. We know the right angle is 90 degrees. Yeah, exactly. So this is 90 degrees here as well. We know that this is 90 and this is 90. Right? But also what we have is sort of a pair of crosses, kind of like we had over here. Right? Because here we've got the same line that's bisecting both this parallel line and this one. Over here we have a similar case as well. Right? Because we have this parallel line and this parallel line, and we have this one coming down and cutting both of them. So it goes here and it goes here. Right? So from that situation there, I'm going to put these out of order, but we know that C, we can tell that is equal to 32. This is corresponding. Right? We know that C has to be 32, the same as this one down here, because this line is parallel with this one, and this is the same line, the same straight line crossing both parallel lines. And if one parallel line crosses one line crosses two parallel lines, we know that all the angles around the intersection are going to correspond with the other one. Angle B then, angle B we can do just 180 minus 32. So angle B then is going to be 148 degrees. And we can do a very similar thing for angle A as well. Now we could have found angle A first. We could have found angle A first by saying, well, it's a whole big triangle on the outside, just looking at the outside triangle. And there's A, 90, and 32, and those have to make 180. Or we can do the same thing from the small triangle, right? We know that C is 32 as well. So either way, we've got A is equal to 180 minus 90 and minus 32. Right? Because we know that all three angles in a triangle have to add to 180 degrees. So that's just 90 minus 32, which is going to be 58 degrees. Okay. Um, yeah, let's take a look at these two, and then I think that will probably be a good intro for Nick there, who is starting work on this unit, I believe. Maybe not today, maybe not tomorrow, but soon. Definitely not for the rest of your life. Maybe for a week. Um, let's draw this out. Okay, got it like that. So we have 67 degrees, 50. Oh, they're taking it easy on us this time. 54 degrees. We've got some unknown D degrees, and we've got some unknown C degrees. Okay, this is an easy one. Oh, it's not C, it's an E. That's E. That's E. All right, so D then, we again know that 180 is the total of all the angles in any triangle. So we're going to have D is 180 minus 67 and minus 54. Right? 180 minus 67 is going to be 113. 113 minus 54 is 109 minus 50, which is 159. Or 59, rather, I mean. 180 minus 67 minus 54. 59, yeah, there we go. Should trust my mental math. So D is equal to 59 degrees. And E over here, E and this 54, of course, make 180 as well. So this is going to be 180 minus 54. So then E is going to be 126 degrees. There we go. Right, good stuff. Let's do one more on this sheet. And I think, like I said, I think Nick will be pretty well equipped to get started on the assignment for this unit. Now, of course, there's no pressure to do math, right? No pressure to do math specifically. Over distance teaching, we do want to enable every student to be able to do whatever course they want, though. So with that in mind, I'm going to make sure that people have notes and examples for their math courses. But if you want to work on English or electives or science, yeah, it's totally your own prerogative. Let me know if you want to work on a science. Let Jennifer know if you want to work on a English or an elective. If for some reason Jennifer's busy, I can send you the English guides, of course, but no reason to do that. I'm sure we're both fairly busy these days, but either one of us will get back to you, in a reasonable amount of time. Okay, there is our diagram. So now for F again, we've got 180 minus 67 is going to give us F. So F is just going to be 113, like so. G, then I'll use a capital G. G is just going to be 180 minus 113. G is going to be 67 degrees. H now is going to be 180 minus 67 and minus another 67. So that's going to be 180 minus 134, which is going to be 46. There we go. That's all. That's all the stuff you got to do, really, to get approaching those ones. Now, remember, when you're doing these ones, us teachers we're tricky. We'll always try to pull a sneaky on you whenever we can. Do not measure these angles with a protractor. Right? So I'll put this in red. Use rules, not rulers. What do I mean there? Use rules, not rulers. Well, basically, like don't measure this. Like don't break out your protractor. right? Now, obviously, I drew these myself, so I didn't even attempt to make them right. But like, don't break out your protractor and be like, oh well, if this is 54 degrees over here, I'm going to measure this angle E, and I see that angle E is actually, oh, it's actually 114 degrees. Well, there we go, angle E, 114 degrees. Put that down. It's not going to work. It's not going to work, Twitch chat, because teachers are sneaky, right? We will generally make sure that the actual angle that it is on the diagram is not the angle that you need to get in order to get the question right, right? And that's by design. It's usually intentional, right? So to stop people from just breaking out their protractor and measuring and then just not learning the rules, right? So you have to use your rules, not your rulers or your protractors. Okay. So that was all the topics I wanted to get to today. Can switch back over to my intro screen. There we go. With my little fuzzy buddies again. Always hanging out and keeping me company, even if they're a little bit sleepy, you know. But I mean, that's what dogs are like, right? They just the sound of someone's voice is soothing in the background, and they're having a nap. If they were here with me now, I'm sure they would be very content to be sleeping, whilst I'm droning on about mathematics. Okay, in my dulcet tones. Yes, very good, very rhythmic and soothing. What a what a sleep-inducing cadence I have. Anyway, yeah, today is it's a bit of an irony that I called it lazy days today because this is the last day of the month, and in this program that I teach in, the last day of the month is like crazy paperwork going everywhere day. It's the most it's the busiest day that we have, and this is distance teaching is busier on average than in class teaching too. It's a fair bit of work, just because of how much longer it takes to do all the communication and stuff, right? Um, but yeah, it's I'm glad to be here doing it. I do think that it's great to be carrying on and helping people learn and improve their education and get ready for when social distancing is over, they can hit the ground running and get out, maybe even have their program finished and then be able to move on to other programs and other schools, do whatever other things people are looking to do, their heavy equipment and I don't know, trades and home care and nursing and oh I don't know, I don't want to pigeonhole people, just whatever in the world you know suppose you want to go to law school, I don't know, gotta go to an undergrad first though, maybe an undergrad in philosophy or classics or something interesting. Anyway, yeah, don't need to keep rambling here. Thanks for hanging out with me today. Hopefully you're staying safe. Yeah, and I'm pulling for you because we're all in this together. I'll see you again tomorrow.